Good day, everyone. My name is Jim Rico Hermoso, and I am here to present to you my ECEA101L project, which is about MOSFET amplifier. Now, what is MOSFET amplifier? MOSFET amplifier is a transistor which uses field effect. MOSFET stands for metal oxide field effect transistor, which has a gate, wherein that gate voltage determines the conductivity of that device. Depending on this gate voltage, we can change the conductivity, and thus we can use it as a switch or as an amplifier, like we use transistor as a switch or as an amplifier. Now, this MOSFET amplifier, of course, has its pros and cons, or as we know, or we can also call this as an advantage or disadvantage of this amplifier or this transistor rather. Now, MOSFET amplifiers' advantages is that they can be operated in either enhancement mode or depletion mode. They have a much higher input impedance compared to JFET. They have high drain resistance due to lower resistance of channel. They are easy to manufacture. And lastly, they support high speed of operation compared to JFETs. Now, that is the advantages of the MOSFET amplifier. Now, let us move on and discuss the disadvantages of the amplifier. In MOSFET, the layer between gate and channel is very fragile, which is vulnerable to electrostatic damage during installation. It requires well-designed circuit to avoid the issue. Then the second and last is that MOSFET is very susceptible to overload voltages. Hence, special handling is required during the installation. Now that we know what MOSFET amplifier is, and we know the pros and cons or the advantages or the advantages and disadvantages of this device, we are now going to move on and talk about the LT Spice so that I can show you rather the simulation that I have made and how does MOSFET amplifier works. So here is the circuit I have made here in LT Spice. Here is the design of my circuit. This is composed of 2 voltage sources, 3 capacitors, 3 resistors, and the MOSFET. So the first thing that we are going to do in this project is to get the values of all the components of this circuit. And the thing that we're going to do that is type a command, which is the .op. And then the next thing that we're going to do is press run so that we can get the operating point or the values of this component or this circuit. So as we can all see, the value for the VN001 is 10. For VIN, it's 0. For VG is 3.333. For VVD is 6.87108. For VVS, it's 1.564 per 6. For Vout, it's 6.87108. And for ID, it's 0.00312892. For IG, it's 0. For IB, it's negative 5.31162. For IS, it's negative 0.00312892. For I, it's 1.56446. And so on and so forth. Now, the next thing that we're going to do to get the values for the to get all the values of this component is for me to type the commands needed so that I can get all the values. Now, the first thing that we're going to type, or the first command that I'm going to type is that tran 010M 0. Then after that, it's .mesh or measure VIN. Next is measure Vout. Next is measure AV. Next is measure T1 and find time when V in is at 0. Next is measure TA. Next is measure and lastly uh, we're just going to recheck all the commands so that we won't get any malfunctions for this circuit. We're just going to put that command there, and we're going to press run and hope that the commands that I just placed will work and would give us all the values we need for this project. There. With all these commands that I just typed, we were able to get all the values needed for V in, V out, AV, T1, T2, TA, TB, FN, and F out. So for the V in, we were able to get the value of 0.019997. For V out, it's 0.065221. For AV, it's 3.2611. For T1, it's 0. For T2, it's 0.01. For TA, it's 3.38639. For TB, it's 0.0009966169. For FN, it's 1,000. And for F out, it's 1,003.85. Now we were able to show how the circuit works, and we were also able to show all the commands needed to get all the values needed for this project. That concludes our video, and I hope that you all learned something from this video presentation. Thank you.